Okay, go. Our next presenter, please. You can tell them a little bit about yourself.
Okay,
And have
well, all right, if you want a little history, let's see, I got my first ham license in 1964. That was a novice class license. There was a bunch of us in high school who spent the entire winter, one winter, and doing basically what you're doing here. Once a week, we'd go and have classes. We'd have a class for an hour, and then we'd have an hour of Morse code. You don't have to do that anymore, so you're halfway there. But we did that all winter, and then when spring came, we took the test. And that was my first introduction to ham radio. Been licensed pretty much ever since, with different classes, but upgraded to my current class in 2012. I think it was 2010, maybe, the extra class. At that time, that was right after the FCC eliminated Morse code. I just wasn't able to get the 22 words a minute Morse code down, so that's why it took me so long to upgrade. But as soon as they eliminated that code requirement, I was there. And a lot of you, my dad was the same way. He just couldn't hear the code for some reason. So he actually had a doctor sign a slip saying he can't hear this, so don't require it. So he got his licenses without having to learn the code. But anyway, so we're going to finish up today with this next section, section T7. Station equipment, 4 questions in 4 different groups. And if you don't mind, I'm going to stand for most of this. In my day job, I work at SUU and teach computer graphics class. I'm also the broadcast engineer for the university radio station and television station. So that's kind of my background, but the reason I got into ham radio was because of the technical side of things. That's where my expertise and interest lies. So. All righty. So we're going to just begin, and as you look at these, all they give you is the correct answer, right? So there are 3 other answers going to be on your test. They refer to those as detractors or distractors, or whatever you want to call them, but they are plausible answers for the question. So if you understand the material they're asking when you take your test, sometimes you can eliminate things if you're a little bit unsure of the question. Just eliminate things that you know it can't possibly be, and that narrows it down. And then you can take your best guess. And I've heard Ron tell people before, you know, it doesn't cost you anything to guess, and you might get it right. So at the very worst case, if you can't come up with the right answer, take a good guess, and you just might get it right. Okay. You have to pass the test, I think, with 74%. And you have 35 questions. So this is just 4 of those 35 questions, okay? So Gavin had the whole thing up there. I just put the blow up of the pictures. So I'll approach it just a little bit differently than he did. But we're going to start out with question number T7A01. Which term describes the ability of a receiver to detect the presence of the signal? So you've got a receiver sitting there, turned on, hooked to an antenna. How's the receiver know that there's a signal there for it to do anything with? Okay. So the term is called sensitivity, And what that means is basically that if the receiver is sensitive enough to understand or detect that there's a signal there, it can take it and amplify it so you can hear it, right? Well, different kinds of receivers have different sensitivities. And you don't need to know all of the technical terms about why or any of those kind of things unless you're curious, and we can talk about it. But I don't want to confuse anybody with needless information. So if you want to know some of these terms and meanings, we can talk about them. But otherwise, we'll just say, okay, that term is sensitivity. And the more sensitive the receiver is, the easier it is for it to latch onto a signal and amplify it. Okay? That makes sense. When you buy a receiver, you will look at one of the specs that a receiver has as you buy it, and one of those is sensitivity. Okay? And it just tells you how sensitive the receiver is to picking up those radio signals and doing something with them. Okay? Sure. It's rated in what we call microvolts per meter. Okay, and I don't know if that means anything to you at all or not, but when a signal is transmitted through the air, it's an electrical signal. Okay, so the stronger the signal, the higher that rating is. Okay, so a good quality receiver would have a sensitivity of maybe 0.2 microvolts per meter.
So then the microvolts would go down with the lack of sensitivity.
So microvolts is 1,000th of a volt. So we have volts, we have microvolts, we have millivolts, we have kilovolts. We all use those metric scales. So if you learn those micro, milli, kilo, mega, you know, we're just referring to the number of zeros before the dot or after the dot. Okay, so receiver sensitivity is rated in microvolts. Go ahead.
So we're talking about the receiver, but can the antenna have something to do with the increase?
Yes, you remember when Gavin was talking about the quality of an antenna? If you don't have an antenna is basically a tuned circuit. Okay? And I don't want to go into the physics of that because I don't want to get you all lost, but an antenna is basically a tuned circuit. And so we have different sizes of antennas or lengths of antennas for different frequencies. So if your antenna is on the wrong frequency, even if you've got a good quality receiver, you're not going to hear anything. Okay? And on the other side, if you've got your antenna that's a good quality antenna on the right frequency, but your radio is tuned to the wrong frequency, you're not going to hear anything. Okay? So the best scenario is to have a good quality receiver and a great antenna. Okay? So those two factors will help make a good receiving system. Okay, what is a transceiver? It's a unit that combines the functions of a transmitter and a receiver. Okay, so most all of you have one in your pocket. Okay, that's just a radio transceiver. Transmits and receives radio frequencies. So why don't you have to have a license to run one of these? Okay, because it's a different frequency and because the power is so low. Okay, you probably
should have a license to operate.
yeah, some of us should have a license to operate one. Okay, but a lot of it depends on the frequency that they're using, and then the other is the power of the transmitter. Now, the power of these transmitters is pretty low. Otherwise, you couldn't carry it around in your pocket or your purse all day long. It'd start burning holes in your body, okay? There's been some controversy about that over the last while, how much of it is safe and some of that kind of stuff. So, but that's all this is just a transmitter receiver. Okay, there's some other circuitry in there that discriminates so that it knows that I'm the one using it on that particular frequency at that particular time.
That's all, they can call you back too.
Yeah, so they can call me back. So when I dial somebody's number, it sends out a little code. So the tower over there knows that it's me. And my phone, when it gets received, it gets the code and decodes it and says, okay, that's you. You can listen to this conversation. Okay? So it's very simple. So that's a transceiver. This is a transceiver. This one is a ham transceiver. Okay? We call it a handy talkie. Okay? Okay? This one works on the 2-meter band and the 70 centimeter band, which are allocated by the FCC for ham radio use. And it happens to be the two most popular bands for technician licensees to use. Okay, there are a couple of others that are used somewhat too, but the most common and popular are 2 meters and 70 centimeters. Okay, pardon me? 70 centimeters. Mm-hmm. And what that's referring to is just the frequency that it operates on. Now this one has about 5 watts of power. Okay, and that's not a lot of power. We'll talk a little bit in a few minutes about how we get around having low power with some of these kind of devices. But because of the frequency being used, it has to be licensed. Okay, so somebody just can't pick it up and start talking on it. They have to have a license to use it. Okay, we can get very large, sophisticated units. This one, I think, cost me about $300 about 15, 20 years ago. Today, we can get them that do basically the same thing for about 40 bucks. Okay, maybe not quite as solid construction. This one's waterproof to about 4 or 5 meters, but some of the others are not. Yeah. Mm-hmm. Amazon's a good place to get them. Mm-hmm. There's a company, in fact, there's one right here, it looks like, Baofeng. Is that what that one is? Okay, the Baofeng model UV5, I believe, is around 35, 40 bucks.
It's down to about 22, 25.
Is it now?
And I have the CD disc software to program it.
That was the question, if you went and found one of these.
Yeah, there's a lot of people around that have just a little cable you can plug into your computer, into the radio, and it programs it.
But do you have to sit there and put in frequency and
You can do it manually, or you can download it into the memory.
or find somebody who's got the same radio, compare it?
Sometimes you can do that. Usually we just do it between the computer and the radio.
And you guys would help us.
Yes, they programmed mine when I first got it.
That's one of the advantages of being in the club, right?
That's right. Or knowing somebody who can do that. Different radios have different kind of programming. So the Baofengs are fairly common. QITs are fairly common. BTEC is fairly common. There's a TYT brand that's fairly common. The big names are Yaesu, Kenwood, and ICOM, and they're more money, but they're also built more ruggedly. So we're going to basically, and have a lot more memories and a lot of other features.
I had my iPhone handheld that I have had since '93, and it still works.
Yeah, and I've got 2 or 3 others of these laying around my house that I don't use anymore because they're old enough. They don't have some of the modern capabilities that this one does. So,
It's probably on and off again, but
sure.
can you get a little radio like that
Mhm.
and put it in a charger thing in your car? It goes to a better antenna?
Yeah, the antenna just unscrews and you can connect
Because the antenna would be the limiting part of it.
part of it. Yeah, so I can just, in fact, I have one on my truck. I just want to get in the truck, I unscrew this antenna and screw the roof mount antenna onto it. Or you can buy a mobile radio that you can leave in your vehicle all the time.
Microphone.
It just has a separate microphone. And you can get all kinds of radios. The sky's pretty much the limit. So just depends on how much money you've got to spend and the features you want.
What's the distance on that?
Pardon me?
What's the distance on that radio?
Okay. In the 2-meter band and the 77 centimeter bands, the distance is basically line of sight. Okay. So we get around that by using repeaters, and we'll talk about that when we get to the repeater question here in a few minutes. But basically what happens is I can transmit from this to a mountaintop that picks up the signal and then rebroadcasts it back down to surrounding areas. And the repeaters can talk to each other. So we've got a repeater down here on Frisco Peak, if you know where that is. The repeater on Frisco Peak talks to a repeater down here on Utah Hill. And that one talks to one up at the Snowbird Ski Resort. So using just these little radios like this, on the right repeaters, you can talk from Idaho to Arizona. If you know how to do it and how to access the systems. And it's not that hard to do. You just have to be on the right repeater and make sure nobody else is using it. That's one limitation, is that you can't have two people talking on the repeater at the same time. Okay, you have to, it's kind of a shared resource. Okay,
And what other thing, if you don't have anything you want, if you have something you don't want everybody else to know, keep your mouth shut, because the whole
yeah,
state's gonna hear it.
that's exactly right. Thanks, Sylvia. Okay. All right. So the next question, which of the following is used to convert a radio signal from one frequency to another? The answer is a mixer. Okay, a mixer is just a device that we can put the signal from one thing into, and it mixes two signals together, and the signal that comes out of the mixer is either a sum of those two or the difference of those two. Okay, so for example, if I had a frequency on 10 megahertz and another on 20 and put it into a mixer, I could get out a 30 and a 10. Okay, so depending on what kind of frequencies you put in. So the purpose of a mixer is just to combine two frequencies. The sum of the two frequencies and the difference of the two frequencies that goes into the mixer. Mixer is a circuit that is fairly common in these. Usually in this, it's just one little chip that does that. Okay. But what we do is we actually start out on a fairly low frequency, and then we mix it up to get it to the actual high transmitting frequency we want. Okay, it's a little more difficult technologically to produce a signal right at 2 meters. So we start out low and mix it to what we call an intermediate frequency, and mix that to maybe another intermediate frequency, and then take that one and amplify it, and that's the one that gets transmitted. So that's a fairly common thing. All right. What term describes the ability of a receiver to discriminate between multiple signals? So you've got two channels in your radio right next to each other, and somebody's talking on one channel, and you want to talk to somebody on the next adjacent channel. Okay, so we have to have some way of differentiating between those signals. So that's referred to as selectivity. So just think of selecting the right frequency. Selectivity. That's a function of what we call bandwidth, but you don't have to know that for your technician license, so don't worry about it too much. Just remember that if you have two signals that are close together and you want to discriminate between the two, then you are using selectivity to select the frequency that you want. Okay. What is the name of a circuit that generates a signal at a specific frequency? Okay, an oscillator. Oscillators are used for a lot of different things. Okay, if you're using Morse code and you hear the da-da-da-da-da-da-da, that's an oscillator. Okay. Oscillators can generate signals at audio, or they can generate it at radio frequencies like transmitter. Okay. So an oscillator is just a device that generates a signal on a specific frequency. And again, this has an oscillator in it. In fact, it probably has a couple or three oscillators in it. Okay. For a transmitter, they are very stable because we can't have the frequency shifting around and drifting around, or the person we're trying to talk to doesn't know where we are and tries to follow us around and can't. So it has to be very stable. The other thing is that we can't be bouncing around in frequencies because that might just bounce us out of the ham channels, and then we get a notice from the FCC of a fine. So we have to be careful of that too. Okay.
Do you not want the lights on?
Pardon me?
Do you not want?
No, we've got a projector.
Oh, okay. Pick the board. Okay.
Yeah.
You're fine.
Thank you. Okay, so the oscillator in here is very, very stable. The way we make them very stable is by using either a crystal controlled circuit, which is basically a rock that when you run electricity through vibrates. Okay, usually they're quartz crystals. In the old days when the novice exam or license was available, when I first was licensed, the FCC required that novice operators couldn't vary the frequency of their transmitter with a knob. You had to use specific frequencies. So the way that we did that is we would buy a little crystal in a little holder that had two prongs in it, which plug in to the transmitter, and that would then select the frequency that we were going to operate on. So we called that being rock bound. But it guaranteed that the novices, those who were not familiar with electronics and so on, didn't get off the channel they were supposed to be on. Okay, so this has basically crystals in it that oscillate at a very specific frequency to generate the frequency that then gets multiplied up in the mixers to put us on the right channel that we're going to actually end up transmitting on. Okay, so oscillator, yes. Yeah, that's part of your license requirements, is that you know what frequencies are ones that you can legally use. Okay, that's going to be one of the elements on the test. What frequencies can a technician class use? And there's a range of them. So, for example, 144 to 148 megahertz. Okay, that's a range of frequencies that you can use. Okay, different classes of licenses have different bands of frequencies they can use.
And they don't make a tech radio, just.
In fact, that sheet that Linda gave you, okay, that tells you what frequencies are available. And it's your responsibility as a ham operator to make sure that you're staying within your class of license on your frequency. Some of these radios, like the Baofengs, can tune all kinds of stuff. Okay, and some of that stuff is not on the ham bands. So you have to be a little careful and make sure that you've set it to the right frequency before you transmit. You can listen all you want, but you can't transmit unless you're on the right frequency. Okay, anything else on that? All right, what device converts RF input and output to another band? Okay, so here's a picture of a device that does that. It's called a transverter. Okay, usually transverters work on fairly small signals. So for example, if I wanted, using the example up here, to go onto a higher frequency like the 13 centimeter band instead of the 70, if I had a transverter that would convert 70 centimeters to 13, I could just plug my antenna into the transverter and it would then convert that lower frequency to a higher frequency and take that out and hook it to the antenna. Okay. My observation is that they're not used a lot by most people, but you still can get them, you can still use them. You can build your own if you'd like to. Okay. Again, part of the responsibility to make sure that it works right and is on the right frequency is with the ham operator. So you don't have somebody looking over your shoulder with a stick beating you if it's not working on the right frequency. That's up to you to make sure that it works correctly. Okay. All right. What is meant by PTT? Push to talk. So on this little transmitter, I can get the case off. Come on. There. There's a little switch on the side. Okay, in this function, it just receives. If I push the button in, it switches and transmits. Cell phone does that automatically. You don't have to tell it I'm transmitting now, I'm receiving now. But with the ham, you do. So you push the button to talk, release to listen. As you're doing that, just as an aside, don't start talking as you're pushing the button. Because generally speaking, you don't get the button pushed in all the way. And so you've said a word or two, and part of it doesn't come through. So push the button, wait a second or two before you transmit. That way you don't get everything cut off. Otherwise, sometimes one of the first things you transmit is your call letters. So you hold down the button and then you pause for just a second or two and then speak your call letters. Okay, so hold down the button, KA7J, then release the button. Okay. And it's just a courtesy to do that, because if I just start saying K7J as I'm pushing the button now, somebody on the other end is just going to hear 7J, because it cuts off or the first part of it doesn't get transmitted. So kind of get in the habit as you're using the radio to key it first. We call it pushing the button. Push to talk, we call keying the radio. So we just key, pause briefly, and then talk. Okay. The other reason for doing that is that on a repeater, the radio sends out a tone. You don't hear it, it's a subaudible tone, but that tone activates the repeater. If the tone isn't there, the repeater doesn't come on. So when you key the mic or key the transmitter, it sends out the tone. That gives the repeater just a second or two to hear the tone, decode it, decide it's okay, and then turn the repeater on. Okay.
That's a PL tone.
It's the PL tone. Mhm. And every repeater, or not everyone, but most repeaters have them. If you go on the radio, on the arc.info website, there's a list of all the repeaters and the PL tones associated with that repeater. So the one that we use most often, I think, is a tone of 1, 2, 3, right? And then the others are just 100s, I think. So it's 123 hertz, which is low enough that most people can't hear it, but the repeater can hear it. So when I transmit and the repeater hears that tone, it says, oh, okay, somebody wants to use me, I can turn on. Okay. And then when you release the button, and then when you release the button, it turns back off. You can also set up your radio to do that. So you could set up, for example, a private line if you wanted, so that your radio ignores everybody unless they send the right tone to your radio. Most radios have that ability now. Okay. So if you don't like all the noise and chatter and say I wanted to hear Sylvia and nobody else, then I would tell Sylvia, okay, you got to send that tone or my radio won't turn on. And then she plugs it into her radio so that when she transmits, it transmits that tone, then my radio hears it and turns on. Okay, questions? All right, fun things. All right. Okay, which following describes the combining of speech with an RF signal? All right, when I speak into my microphone, that's an audio signal, right? Well, how do I get my audio signal, my audio message onto my transmitted signal? That's a process called modulation. Modulation is just a big word for change. That's all it means, just change, okay? So the slide here shows two different kinds of modulation. There are lots of other kinds, but these are the most common ones. The one on the left is called amplitude modulation. And what that means is that when I push the button on my radio and start talking, the signal is combined, my voice is combined with the signal that the radio is sending out. And so what I end up with is this larger part is this audio signal. Okay. The smaller part is the frequency that I'm transmitting on. The radio at the other end then does what we call demodulate that signal and recover the audio from it. Okay? So it's that simple. The other type of modulation is a little more complex. It's called frequency modulation. So we have a audio signal coming in, and then here's the transmitter sending out signal, And you can see that as the signal is transmitted, the frequency is varied slightly. Okay, and the frequency is varied proportionally to the audio signal. Okay, so if I talk at a higher frequency, that moves the transmitted frequency carrier wave a little closer together. If I talk at a lower pitch, then it moves a little further apart. Okay, so we're actually changing the frequency of the transmitter slightly to use FM. Now, what's the difference? What's the advantages and disadvantages? FM is inherently fairly quiet. It's also fairly high quality. So we say it has better fidelity. Okay? It's inherently quiet. AM is inherently a little more noisy because as the signal goes out, if there's a lightning strike, say 10 miles away, that lightning strike can actually hit the carrier and cause noise spikes to be generated that get sent right along with the radio wave. So when it gets to the receiver, in addition to hearing the sound we want, we might be hearing noise crackle from lightning or a transformer that's got a problem on the pole next door, or a lot of different things that are strength related. Amplitude, meaning the strength or the variation of the high and low parts of the signal. FM inherently ignores that to a great degree. Okay, well, most people use FM on 2 meters and 77 centimeters. There are parts of the band that you can do other kinds of modulation, but most people, at least when they're beginning, use just FM. Okay. Questions about that? That hopefully makes a little bit of sense. So modulation is just a change in the frequency. Okay. What is the function of an SSB CWFM switch on a VHF power amplifier? So we've got a transmitter here that's a little more sophisticated than my handheld, and it has a little switch on it that says SSB, FM, CW, AM. So what's the purpose of that? It just sets the transmitter for the proper type of modulation. Okay. Or for the selected mode. Okay. All right. You don't see those as much on mobile 2 meter or 70 centimeter radios until you get into the higher quality ones. And then some of the higher quality ones, we have people in the club who like to go out on mountaintops and try to contact people by television, slow scan television, or to see how far, in fact, Linda does this sometimes, single sideband, see how far we can contact on single sideband across the country. And it's surprising how far they can get sometimes. Okay. Yep. Okay, and fairly low power. Fairly low power. Okay. So let's say I've got my handheld here, and I'm trying to talk to a repeater, and I'm just not quite making it into the repeater. I'm just far enough away that my signal is weak. If you remember Gavin's example of the headlight, Same thing is true here. The further you get away from the source or the transmitter, the weaker the signal gets. So we've got to figure out a way of improving the quality of the signal. We can do that one of two ways. One is that we get a better antenna that's directional and points it the way we want it to go. The other way is to increase the power of the transmitter. And to do that, we use a device called a RF power amplifier. So you can actually buy little power amplifiers for these things that you can boost, like the 5-watt output of this up to 50 watts. Okay. And then hopefully that helps you to get into those fringe areas a little better. Okay. On the other end, with the received signal, sometimes the signal is low enough that we want to boost it a little bit before it gets into the radio. Okay. And so there we use what's called a preamp. Preamp is basically just an external amplifier that's connected between the antenna and the receiver. And its purpose is just to increase the strength of the signal coming into the receiver. Okay, again, like you talked about, if there's noise on the line, it's going to increase the noise as well. But sometimes that's what we have to accept, is a little more noise to get the signal we want.
I just did that with an outside TV antenna.
Mm-hmm.
And I was really surprised when I didn't put it on, the amount of channels I got, 8 or 9.
Mm-hmm.
I put that power unit on, now 34 channels.
Right. Yeah. And with the current TV technology that's digital, the increased noise gets rejected, so you don't have to worry about it. Or with an FM signal, it's minimized, so you don't have to worry about it as much. Okay, but it's for receiving only. So you have to be a little bit careful if you're using a preamp that you don't transmit back through the preamp, or you could burn it up. Okay. All right, let's move to the next section. Common problems. This is kind of an important section because one of the things that people like to complain about ham radio operators is, you're getting into my TV, or you're getting into my telephone line. Okay, so we need to know a little bit about what to do if you get into that kind of a situation. Okay, so 7B1, what can you do if you're told that your handheld or mobile transmitter is over deviating? Okay, so what do we mean by deviating? Remember, the FM signal changes up and down a little bit, so what we're doing is deviating from the carrier, from the main frequency. So frequency, for example, is 144. It might deviate below 144 a little bit, above 144 a little bit. The louder the signal, the further it deviates. So how do you know if a signal is deviating too much? Yeah, it starts sounding pretty crappy. Okay. It sounds muffled, distorted. Okay. On the other hand, maybe it sounds really weak, faint, like maybe you're talking across the parking lot or something like that. So how do you rectify those kinds of situations? If you're too loud, you just move the microphone away a little bit so that it's not catching the full force of the sound. If it's too quiet, then you bring it a little bit closer. Okay, so it's deviating a little better. Okay, so part of that is just getting used to your radio and knowing how to work with it with your own voice. Someone else could use the same radio and have to work with it a little bit differently because of the way their voice is. Some of us speak quite softly, some of us speak quite loudly. So that's just a matter of getting used to the way that your radio works. So over deviating just means you're pushing your frequency signal out too much. And the receiver isn't able to receive that, so it just chops the signal off and makes the sound quality really bad. So it sounds like you're talking with a skillet over your head or something, right? All right, what would cause a broadcast AM or FM radio to receive an amateur radio signal? All right, let's say that you've got your station up, your antenna's up on a pole, and you've got a neighbor that's TV antennas on another pole about 10 feet away. Okay? Every time you transmit, your neighbor comes and beats on your door and says, hey, you're causing problems for my TV. Okay? Generally speaking, that problem is that the receiver, notice the terms here, the receiver is not able to reject strong signals. So it's the neighbor's fault. Now, it's not technically his fault. It's probably the fault of the manufacturer because they're going to make their TVs as cheaply as possible, right? And so they're not going to do that now. And if that doesn't come up, we'll talk about there's some things here that we can talk about a little bit, but what happens basically is that the receiver circuit is so sensitive in a strong radio environment that it can't distinguish between things that it should be receiving and things that it shouldn't. Okay? And so the signal, regardless of what the frequency is on, just basically commandeers the TV. Okay?
With the satellite TV, it doesn't happen as often.
Not as much, but it can.
Still can.
Okay, if your transmitter is really strong and is in the path of the dish, it could still happen. Yeah. Okay. All right. Which of the following can cause a radio frequency interference? Okay, fundamental overload, which is what we were just talking about. The signal is so strong that it just overloads the receiver. Just commandeers all of the circuitry in the receiver, and the TV can't do anything. Just kind of curls up in the corner and quivers and says, I don't know what to do. So I'm going to do what's the strongest signal is. Okay? Harmonics. Whenever you're transmitting a signal, technologically speaking, it's almost impossible to make a transmitter that transmits only on the frequency it's supposed to transmit. Okay? So what we do is, for example, okay, I'll just use this as an example. The university radio station operates on 91.1 megahertz. Okay, I could pull it up actually, and we could look at it here on the computer if we wanted to. But there's a little kind of a mountain shape waveform that I have to watch that tells me how much of my signal from that radio transmitter is actually getting out on 91.1 and how much of it is actually at 182.2. Okay. So that's called a harmonic. Anytime you have a radio transmitter, you're going to generate those harmonics. Okay, so if you're on a 10 megahertz transmission, your radio is going to generate harmonics at 20 megahertz. It's going to generate one at 30 megahertz, one at 40 megahertz, and so on. They get weaker and weaker the further you get away from the basic or fundamental frequency. So the FCC requires us to keep those harmonics as low as possible. Okay. And there's some ratings there that they look at, but you don't have to know that for your technician class. It's rated in what we call decibels per meter, dBm. Okay, and we say, okay, the first harmonic has to be 60 dBm below the fundamental frequency. Okay, and then each subsequent harmonic has to be lower and lower, but it's still there. So if somebody wanted to go out and sit under the radio station antenna with a radio that turned 180 megahertz, they could tune it in. Listen to it all day long if they wanted. Okay, and the further you get away, the weaker it gets until it's pretty much gone. But that's just a function of the radio transmitter. Okay, so if you're transmitting on a frequency that is a fundamental frequency of a TV channel, for example, again, and your neighbor is watching that particular channel, it's possible that the harmonic of the signal you're transmitting on could get into his TV. Okay, that's a possibility. Doesn't mean that it would have to happen. It's just something to be aware of. It's a possibility. Okay. All right. So the third answer is spurious emissions. Spurious emissions are generally caused by problems in the transmitter. And they are signals that we don't want that the transmitter generates anyway. That's why they're called spurious. And they have to be attenuated by FCC rules way, way, way down. Okay. And we do as much as we can to eliminate them altogether. But spurious emissions are emissions that the transmitter might generate on frequencies that we don't want. And that could cause interference. Okay, so which of the following can cause radio frequency interference? All of them can cause that. Okay. So how can we eliminate those? Let's say our neighbor is insistent that we do something about our transmitter so he can watch his TV or so he's not listening. And by the way, if somebody has got your signal on their telephone, their landline telephone, there's something wrong with the telephone. Okay? Because it's not designed to pick up that kind of material. So if it's doing that, there's a problem there. Okay, but what's a way to reduce or eliminate that interference? Okay, we put a filter on the phone. What kind of filter are we going to put on? Okay, there's a look at one right there. Do any of you have internet, DSL? Okay, when you got your DSL internet, they put a little filter on the line somewhere. Purpose of that filter is to block that high frequency signal from getting onto your phone line. Sylvia?
Is there any filters that you know of that will 2-meter signals from going across phone lines.
You can get the filters.
For 2 meters,
Uh-huh. Yeah, they have to be pretty much what we call band reject filters.
I need to talk to you afterwards.
Okay. If you're having that problem at home, where you've got 2 meters and it's getting into your home phone, there's probably something wrong with the phone or with the lines in the house. But you can get a filter or make a filter that will block that. You remember that there were parallel filters from Gavin's discussion. Parallel filters are low impedance. Series are low impedance, parallel or high. Okay, so if we put a parallel filter in here that's a high impedance, it's going to block that RF from getting into the phone line. Okay, you can get them for FM, at least you used to could get them for FM to block signals into the phone line as well. Radio Shack used to sell them. They're not in business anymore, but had just a little knob on it. There was a variable capacitor, and you just stick that in your phone line and tune it until the signal was gone. Okay. I've got one at home someplace. I don't know where it is exactly. Okay. But it's just a line filter on your telephone line that blocks those. How can overload of a non-amateur radio or TV receiver by an amateur signal be reduced? So now we got just the opposite thing. Somebody's TV is making noise and causing problems for your receivers. The solution is basically the same solution in that we just put a filter on our antenna that blocks that interference. Okay. So it's kind of the same problem. Which of the following actions should you take if a neighbor tells you your station's transmission is interfering with their radio and TV signal? So the neighbor comes and beats on your door, you're interfering with my signal. What's your responsibility? What's that? Okay. What if it's not your problem? Okay. People in general don't want to admit that their equipment has problems. That's just the way that we are. That's not my fault, it's your fault. You're the one who's transmitting, so it's your fault.
Did you test that with, have your TV on
You could.
and talk and see if it interferes? If it doesn't, then it's.
Yeah, you could do that. Okay. Okay, so the answer is make sure that your station is functioning properly. So that's your responsibility, is to make sure your station functions properly. And it does not interfere with your own radio and TV when tuned to the same channel. Okay. If it does, then maybe there are some things you need to look at fixing. Okay. Generally speaking, the FCC looks at interference problems from the consumer electronics standpoint. That is, they will normally assume that it's the consumer's product, television or radio, that's got the problem, unless they can document that it's your equipment. And they can do that too. So if you happen to go outside and see a big white box van in front of your door with antennas sticking out all over the place, you know that there's an FCC examiner there listening to what you're doing. If it is your problem, then you're obligated to resolve it. Normally, it is not your problem, especially if you've done due diligence to make sure that your signal is clean. Okay, how do we do that? We make sure that any fixed equipment is properly grounded. Okay, and there's a section on here about that. Okay, we'll talk about that in a minute. But if you're causing that interference, you need to fix it. What can reduce the overload to a nearby FM station? A band reject filter. So that's what a band reject filter looks like. It's not the only configuration, but it's what some of them look like. Okay. And it's called band reject because it rejects frequencies in a range or band of frequencies. Okay, and it just basically reduces them to the point that the receiver doesn't get bothered by them. Okay. What should you do if someone in a neighbor's home is causing interference to your station? Okay. Consumer electronic devices are notorious for generating spurious RF. Okay, like the hair dryer Gavin talked about. Okay, that can generate electrical signals. Okay, you may be driving around town with your radio, and as you pass certain places in the radio, suddenly you hear a buzz in the radio. The squelch opens and there's noise there. Get by a power transformer and suddenly your radio turns on and there's noise there. Consumer devices are notorious for generating noise. Okay. So what do you do if the neighbor's home is causing you problems? You work with the neighbor to identify the offending device. So you may have to have him turn his mixer on and off and listen to see if that's the problem or whatever the case may be. Okay? And hopefully if you're having these kind of issues, you're congenial about it and you're willing to work with people. You know, and say, hey, you know, I think there's a problem with your fish tank's air pump, or whatever the case may be. They may be happy to get it resolved because it's going to save them some money. It's not wasting power generating RF. Okay. Politely inform the neighbor about the rules that prohibit use of devices that cause interference. So you don't bring your hatchet with you as you're coming. Okay. But you know, I don't know if you're aware of it or not, but the FCC rules require that you not use a device that causes interference to radio communication. Well, that can be a very sensitive issue, so you have to be kind of careful about it. And then check your station to make sure it meets the standards of good amateur practice. All of those are correct choices. All right. Have anyone heard of an FCC Part 15 device? FCC rules are divided into what we call parts. Okay. Some of those parts deal with commercial broadcasting. Some of them work from satellite broadcasting. Some work for power companies. If you can think of an electric device, the FCC has rules about it. And there's a part of the rules associated with it. Okay, so Part 15 of the rules say that unlicensed devices may emit low radio signals used by a licensed device, as long as it doesn't cause interference and problems. Okay. So if you look at a device and you see that sticker that says this device complies with Part 15 of FCC rules, that's what they're talking about. Okay, it may not cause harmful interference, and it must accept interference from other outside sources. All right. So be aware of that. The other thing you need to be aware of as far as FCC parts are concerned is that when you buy a device like this, it has to be certified by the FCC before it can be sold. Okay, so you can go on the FCC website and look up devices that you might want to buy, radios, and make sure they're on the list of accepted devices. If it's not on the list, you probably should stay away from it. Okay. The Baofengs are on the list, even though they do have capability of transmitting on non-ham frequencies. You just need to be a little bit careful with them. Okay? What might be the problem if you receive a report that your audio signal through a repeater is distorted or unintelligible? Okay, so your receiver, your transmitter may be slightly off frequency. Okay, and that may allow the repeater to detect it and turn on, but there's so much noise and distortion there that nobody can understand what you're trying to say. So that could be a problem. Your batteries, notorious batteries in these things, as they run low, sometimes that can cause problems with hitting the repeater. If you have the ability to monitor the repeaters, sometimes you'll hear that somebody's just scratchy and those kind of things and totally unintelligible. It may be that they just forgot to charge their battery up. Okay. Or maybe you're just in a bad location where your signal is having a hard time getting through. Okay, and so all of those choices are correct. All right, what is a common symptom of RF feedback in a transmitter or transceiver? RF feedback, that's kind of like audio feedback. And somebody stands up in front of the microphone and they talk and it starts squawking at you, that's feedback. That can happen with a radio transmitter as well. So what is a symptom of that? Reports of garbled, distorted, or unintelligible voice transmissions. Okay. All right. What should you do to resolve cable TV interference? So your neighbor's got cable TV and has some interference that he thinks are causing. What do you do? Okay, make sure all of your connectors are installed properly and that the connections are tight. It used to be fairly common in town that you could drive around with a battery-powered TV receiver and turn it on to the cable channels, and as you drove down, you could watch the cable TVs because the cable signal was leaking out of some of the places along the line. And you could watch the TV as you drove down the street. Okay, this is just the opposite problem. If somebody is complaining about your radio transmission getting into their cable TV, you want to make sure that all of the TV connections are correct and tight. Okay. Sometimes those connectors wear out. Sometimes they work loose. So make sure that they're all solid and tight and that you can't just pull on the wire and have the wire come out of the connector. Okay, so make sure that those are there. And then make sure that on your end, all of your connections are tight so that you're not radiating things you shouldn't be. All right. All right, so this diagram here is just a basic diagram of a repeater. And I just thought it'd be interesting for you to look at it so you can kind of see a little bit about how repeaters work. Basically, on these higher frequencies, the radio frequencies attenuate very quickly. That just means that things like buildings and mountains and even people get in the way and they absorb some of the radio frequencies and reduce the effectiveness of your transmission. So to resolve that on the higher frequencies, we've installed repeater systems. Basically, you've got a tower on a mountaintop somewhere, and someone holding the transmitter over here can talk. The repeater picks it up on one frequency and then retransmits it on a different frequency. Okay. So when we're using a repeater, we're listening on one frequency and transmitting on another. That's called the frequency offset. For 2 meters, it's 600 kilohertz. For, yeah.
Well, the repeaters, does weather have anything to do
Weather can affect it.
with it? How bad?
A lot's going to depend on the frequency again. Okay, there's what we call rain fade, which means that the drops of moisture falling to the ground are the right size that they absorb the RF and it doesn't get through. That's generally a problem with higher frequencies in the microwave region rather than in the UHF, VHF region, but it can have some effect. Okay, snow on the antennas can be very problematic.
When
And
it goes out, do your conversation kind of just go to switch to another repeater that's closer by? Or?
you could do that. Yeah. Generally speaking, the problems we have with the 2 meter and 70 centimeter repeaters is that ice builds up on the antenna and then the antenna breaks. Well, that's generally the weather related problems on those frequencies. In fact, it's fairly common on some of the repeaters to have that happen over the winter. There are ways around that, but they're more expensive. We can put heaters in the antenna so the ice doesn't build up, or we can put kind of a shroud around it so that it can't stick, some of those kind of things. Yeah.
Most of the repeaters don't require a grid to be energized, solar battery or something.
Yeah, most of our repeaters in our area have battery backup. So they run on the power grid, but when the power goes out, they have some circuitry there that automatically switches to the battery. And the batteries are solar charged. So they maintain a charge, and then they have to go up and swap the batteries out every few years because they, even just sitting there not being used, will deteriorate and decay. Pardon me?
Who's responsible for that?
Um, to a large extent, there's a society in Utah that's called the Utah VHS Society. And they install and maintain a good share of the repeaters in Utah, Idaho, Southern Nevada, Arizona, Wyoming. A lot of the area hams join that society, and then it's like $15 a year. And there's enough people who join that if there are problems, the dues is what maintains and operates the repeaters, pays for the power and buys new equipment and those kind of things. The other thing that can happen is a private individual could put a repeater up. We have in our area several of those. Some of them have been put up by a private person, and then they just say, everybody can use it. So we call those open repeaters. And yeah, I put it up, but I put it there for everybody to use. So, and then we have some that are kind of cooperative, where the club will participate in helping pay for some of it, and the private parties or other clubs may participate in part of it as well. They are governed by FCC rules. Mhm. There has to be a custodian of the repeater who is responsible for its operation, and they have the ability to remotely turn it on and off, and some of those kind of things, and have to monitor it to make sure it's working properly, and all those kind of things. Okay, so basically the repeater is two parts. It's a receiver and a transmitter. Usually they use just a single antenna. Okay, so the antenna comes down in here to a device that splits the signal. If it's receiving a signal, it goes over to the receiver. The receiver decodes it into a controller. And if it has the right tones, the controller says, okay. So it turns the transmitter on. So receives on one frequency, goes through the controller, transmitter turns on, goes back out and up the same antenna on a different frequency. Okay. Just, yep. Okay, so it's a shared resource. So if I want to talk on the repeater and somebody else is talking, I have to wait till they're done. Or if I have an emergency, I can break in and ask them if they would release the repeater because I have an emergency. The VHF Society suggests that you only talk for 5 or 10 minutes, and then release the repeater. And if nobody else wants to use it, then you can resume your conversation. Yeah. During the day, there isn't as much what we call traffic as there is toward the evening and night. And some repeaters have dedicated use, for example, the intertie that ties all of the repeaters together. The one that we use most often here as a club, we have a nightly meeting at 9 p.m. and we use it for maybe half an hour, 45 minutes at night, and we just take turns, and we have a control operator that says, okay, so-and-so, are you there? And you respond, yes, I'm here. Okay, let's go to the next. So we do a roll call. And at the end of the roll call, they'll go back up to the top and then just let people comment. And so it's kind of a shared resource. If there was an emergency, there would be an emergency control station that would monitor the repeater and receive any emergency messages, traffic, and relay it to the appropriate entity, whether it's a local law enforcement or whoever the case may be.
More question.
Uh-huh,
I've heard before about skip. You can,
uh-huh.
is that all?
What skip means, and maybe this is getting a little beyond what we should do, but then we're getting close to time, but basically what happens is that lower frequency radio waves, as they go into the ionosphere, there's a layer in the ionosphere called the E layer, and it's a highly charged particle layer. So frequencies that are low, when they go into that layer, bend. Okay, so they actually bend and send the wave back to Earth. So there's what's called maximum usable frequency, MUF, and anything above that frequency, the frequencies are so short that the ionosphere doesn't affect them, and they just go right straight through. Okay, so it's about around 30 megahertz, depends on the time of day and a lot of other things, but generally speaking, above 30 megahertz, the signal just goes right straight through. Below that, the signal hits the ionosphere and it bends or diffracts the signal, and it just comes back down. So the distance from where the transmitter is to where it diffracts and comes back down is a distance, and that's the skip. So it's kind of skipping part of the Earth, okay? And that can happen multiple times. So it can go up and down and up and down. And that's how you've heard ham radio operators be able to talk to like Japan from Cedar City or Russia from Cedar City. That's how that works. It's usually a lower frequency and the signal just skips along, okay? And that's kind of fun to work. There are a lot of different things you can do with it. You can do satellites. Satellites are usually higher frequency, usually above 50 meg. And the frequency just goes straight to satellite and then straight back down, which gives you a wider coverage because you got satellite footprint you're dealing with. There's what's called moon bounce, which if you have the right kind of equipment, you can send a signal, hit the moon. Signal bends as it hits the moon and bounces back to Earth. So there's just a lot of fun kinds of things like that if you're interested in getting involved in them. Just, you know, it's almost limitless what you can do with the hobby. Kind of fun. All right, we need to kind of finish up real quick here. All right, 7C, antenna measurements and troubleshooting measurements, SWR, dummy loads, coaxial cable, and so on. So what is the primary purpose of a dummy load? So I guess we need to define what a load is first, right? So when I have an antenna connected to my radio, that's considered a load for the radio, okay? If I don't want my signal to go out to other people, then I can install a resistor, and these are just some common configurations for those that we call a dummy load. It's just a resistor that instead of transmitting the signal over the air, turns it into heat and dissipates it inside the device so my signal doesn't go out over the air and interfere with other people. So why do we use it? To prevent transmitted signals over the air when we're making tests. So I want to make sure my radio is working without disturbing other people. I just disconnect the antenna, plug in a dummy load, and then I can test to see if my radio is working right in the dummy load. Okay. All right, next. All right, in general terms, what is standing wave ratio, SWR? What happens with SWR or standing wave ratio is a mismatch between, oh, no, I lost our screen, but that's okay. A mismatch between the transmitter and the antenna, okay? So transmitters have what we call an impedance, which is equivalent to resistance. The standard is 50 ohms. Okay, so my little handy talkie here, my HF rig at home, the output impedance of those devices is 50 ohms. Okay, if my antenna is not matched to that, when the signal goes out and hits that, it's like hitting a brick wall. Okay, and depending on the severity of that mismatch, I may lose all of my signal or a portion of the signal. Okay, so it actually kind of acts like a reflector. If you've taken a piece of rope and just kind of whipped it up and down, you see the waves form. Okay, those are what we call standing waves. If the person on the other end starts whipping their end up and down, we see a wave moving toward them, and then we see a wave moving away from them back to us. That's what a standing wave is. Something that can't go any further, so it comes back. That's not a good thing. If the transmitter sees that and says, wait a minute, I'm not supposed to see that, it can cause problems for the transmitter. So modern transmitters, if that ratio gets too high, will reduce the power to protect the radio. If it's a short, it may still burn things out. Okay, so it becomes important then to match the antenna to the transmitter. Okay, the length of an antenna is determined by its frequency. That's why this can have a very short antenna. Some of them you see that are 40, 80 feet long. Okay, and it's because of the frequency that's being used. Okay. So SWR is in general a measure of how well the load is matched to the transmission line. How do you determine if an antenna is resonant at the desired frequency? In other words, how do we know that our antenna is working correctly for the frequency we want to use? We can buy one of these devices or find somebody that has one and borrow it. Okay, antenna analyzers, they work very well, but they're a little pricey. You can also buy one that's kind of like the one on the right, which is a network analyzer, and they work very well for measuring antenna loads. They're around $70 on Amazon, and they work really well for that. And generally speaking, it's just a simple matter of making antenna longer or shorter until it tunes in to the right frequency. Okay. All right, when reading an SWR meter, it indicates a perfect match when the ratio is 1:1. What that means is that the impedance of the antenna and the transmission line are the same. Okay, 1:1. That's what we want. Okay, but in most solid state transmitters reduce power as the SWR increases to protect the amplifiers. Okay. What does an SWR 4:1 indicate? It indicates that there's a mismatch. Okay, and it's kind of a 4 So if we had a 50 ohm signal and the antenna was loading at 200 ohms, then we have a 4-to-1 ratio. That's way too high for a transmitter, by the way. You don't want one that high. You want to get that as low as possible. But generally speaking, no higher than about 3-to-1. Okay. What happens to power you lose in the feed line? It's turned into heat, just like anything else. Okay, so if we have a mismatch, sometimes our transmission line coax gets really hot. That's what's happening, is that mismatch is causing power to be lost in heat. All right, let's see. So I don't know if you can see that or not, but the way this works is, so here's your source, go down the line, and here's the antenna. If there's a mismatch, part of that signal gets pushed back to the transmitter. Okay, and that causes that standing wave, which can damage the transmitter. Right, how do we determine what that is? We can get one of these SWR meters. Sometimes they're called SWR bridges, and they're not terribly expensive. And what we do with them is hook them between the transmitter and the antenna, and then they measure how much of our power is going to the antenna and how much is being sent back. And that can be measured in actual watts, or it can be measured in SWR. Okay. We got too busy talking. We got to hurry and get done here. All right. Why should we have a UV resistant coaxial cable? Sunlight striking on the insulator, the outer sleeve of a coax, can cause it to break down. If it breaks down, it can get moisture in it. If it gets moisture in it, it's not going to work. Okay, so we want it to be ultraviolet resistant so that it doesn't allow water to get into the cable. Okay. Some coax cables we can get have air insulators. Not very common with ham radio operators. They're fairly expensive, but you can get them and use them. Okay, for example, a university FM station, we use that kind of cable. It's actually called Heliax. It's about $5 a foot. Okay, but it has air around it rather than a plastic foam. The reason for that is that it makes it very stable as far as the SWR is concerned. But then we have to pressurize the cable with helium to keep the moisture out. Okay. More common cables that hams would use would be one of these types. They're a coaxial cable. And for most ham use, they function very well. Okay. What does a dummy load consist of? A non-inductive resistor and a heat sink. Okay, we've already looked at that. All right, real quickly, if you wanted to measure electric potential, what kind of a meter would you use? So what's electric potential? Voltage. Okay, voltage is the potential. Okay. So we would use a voltmeter to measure potential, or more technically, electromotive force. So when we say 110 volts, that's what we're talking about. Okay, the potential or the force. Okay, so we'd use a voltmeter to measure that. Okay, what's the correct way to connect a voltmeter to a circuit? We connect the voltmeter across the circuit or parallel to the circuit. Because what we're trying to measure is the amount of push or potential that the electricity has. So we would measure clear across the circuit. Okay. All right. How do we connect an ammeter to that same circuit? An ammeter now measures the flow of the current through the circuit. So we want to measure the flow, so we have to put it in line with, or we call it in series with the circuit to measure the flow. Okay. What instrument is used to measure resistance? Resistance is measured in units called ohms, OHMS. The symbol for that is a little horseshoe looking character. Okay, we use a ohm meter to measure resistance. Okay, what might damage your meter? Attempting to measure voltage using the resistance setting. Okay, so when we're measuring the resistance, we want to make sure the circuit is turned off. Okay. And when we're doing any other measuring, it's best to turn the circuit off, connect the meter, and then turn it back on, so you don't accidentally short something out. All right. What type of solder is best for use in radio and electronic? Rosin core solder, or at least a solder that uses rosin as the flux. Okay. Plumber's flux, plumber's solder, stay away from for electrical use. It's generally acid-based, which causes the joints to corrode over time. And when a joint corrodes in an electrical circuit, it can create a diode, which then can rectify a signal, and then you get in trouble with the neighbors, or you lose power, or a lot of other problems. So you want to use a rosin core solder. The standard used to be one called 6040 solder, which referred to its tin and lead components. Okay. Anymore, they're using a higher quality solder that's a silver bearing solder. 95.5 is a fairly common, and it uses silver and another metal that's fairly inert, like tin or something like that, so that it doesn't corrode much. It's a little more difficult to solder with, but it works quite well. Okay, we're at the home stretch. All right, cold solder joint. When we're soldering, we need to make sure that we get enough heat to adequately melt the solder. But the other problem is that if you get things too hot, it will burn up your device or destroy your circuit board. So you have to be a little bit careful one way or the other. And it's hard to see with the lights on, but so this side shows what we call a cold solder joint. You can tell it because it looks really dull or grainy. Okay, dull or grainy. What we want is one that is bright and shiny. Okay, and that indicates to us a good solder joint. When you're soldering, generally speaking, you'll apply the heat from the iron to one side and the solder to the other side of the joint. And you heat it up until the solder flows around the device. And as soon as it flows, then you remove the heat. And then it's a good idea also to clean the flux up that's left there because it can cause problems over time. So you can get flux remover, just 90% isopropyl alcohol works fine, just on a Q-tip and clean it up. Okay, so let's say you've turned your radio off, hook your own meter across the circuit to see if it's okay, and the meter changes. It goes from jumps up to a high level and then slowly comes down. Okay, or you hook it up and it starts low, but then it gets higher and higher. You say, wait a minute, I thought this was resistance. It shouldn't change because there's nothing there. Generally what's happening is that there's a capacitor in the circuit. Capacitors store electrical charge, but they don't do it instantaneously. It takes time for the charge to build up. Okay, so as you hook the meter across, there'll be an inrush of current into the capacitor, and then as it reaches its maximum, the current flow stops. So you'll see the meter change. If you see that, that generally is an indication that you're measuring across a capacitor. Okay. Be careful if you're working with capacitors. There are some capacitors that hold a lot of charge, even after you've turned the power off. And people have been hurt quite badly because they figured everything is okay and they reach in and grab across a capacitor and they get knocked on their can. So what you want to do is you turn the power off, disconnect the lines, and then use a jumper wire of some kind to jump across the capacitor to make sure it's discharged. So you don't have to worry about that. All right. Which of the following precautions should be taken when measuring high voltages with a voltmeter? The first thing you want to do is make sure your meter is capable of measuring that voltage, and then that your leads are rated for the voltage to be measured. And again, it's a good idea to turn everything off, hook the meter up, and then turn the power back on, rather than trying to reach in and hold it. You know, some of the transmitters I used to work on at the radio station were, 10,000 volts. You hook a voltmeter across those with 10,000 volts in there, and you accidentally miss. A lot of smoke, a lot of sparks. So be really careful with working with electricity. Any other concerns or discussions? I apologize, we've gone over a few minutes, but hopefully we've gained some helpful information. And like most other people in the club or who'll teach your classes, if you have questions or concerns or anything else that we can help with, be sure to let us know. Most of us are really happy to help you answer questions or work with you in any way we can. And Linda knows how to get a hold of most everybody, and Ron knows how to get a hold of most everybody. So, and if they can't answer it, they know who to go to that can. Yeah. Okay. What's that? Okay. All right, anything else? All right, thank you for your kind attention and good luck on your exam.